Hello students, I hope everybody is good. In the last session we discussed about the functions, how a function call itself, that is basically a recursion, what are sets and what are dictionary. And in the other previous sessions we looked upon the loops, some of the list functions, strings, tuples, and how the variable and other conditional statements are being handled in Python. In today's session we'll learn about the classes and objects. So let's get started. Okay, so this is the day 4. We'll name it as day 4. So, okay. Starting from the classes and objects, let's see how classes and objects are operated. Before starting with the classes and object, let's see what's the need of the classes and objects in programming. Since from the last few sessions, you got to know that we can like directly write the code and execute it. That is basically a functional programming. Classes and objects fall under the object-oriented programming, where we create an object for a particular type of a code, and then using it we create an object. Remember, object is an instance of a class. Okay. So a class in a Python is a user-defined template for creating objects. So what is class? Class is a user-defined template for creating objects. It basically consists of the data and functions, making for the user to manage these and then use them. So what does the class consists of? It consists of data and functions together, meaning the both are comprised inside the class, making it easier for the user to manage and handle them. To manage and use them. Yeah. Okay. So whenever we create a new class, we define a new object. Okay. So whenever you create a class, you basically in Python you basically use a keyword class. So whenever you create a class, you create an object to it. But it is also advisable to create multiple objects for a class for the better uh, productivity of a program. Since to see that better inputs will result in the better output or not. Okay. Also, as I told you, class in Python is created using class keyword. Okay. Okay. Let's see what all things are there inside a class. So there are basically attributes and functions. What are attributes? Attributes are variables. Attributes are variables defined inside the class that represent the property of a class. Okay, so attributes are basically the variables that are defined inside a class and represent the property of a class. Okay. Also, how to access these attributes. To access these attributes, remember, you need to use a dot operator. You need to use a, this is basically a dot operator. We'll see how basically this operator will be used inside a class. Okay. Okay. So now let's see a basic simple code of creating a class. Yes. First, to create a class, you need to define a class. We'll do it using, okay. I told you earlier that to create a class, we use a class keyword. So we'll write class keyword here. And name of the class, let's suppose you want it as dog. And now let's say sound is a variable here that has the value, let's say bark. Okay. Okay. So in this piece of code, what we understood is, to create a class, we need to have an attribute class, then followed by a class name, then colon, and then you need to define the attributes associated with the class. Let's say here the attribute is sound, which has the value bark. Now let's see how we can create an object for this class. Before this, let's see what is basically an object. Object is an instance of a class. Let's say we have a class dog. Okay, so let's see if we have this class only. Okay. Okay, now to create a class, we'll simply write, let's say the name for an object of this class is, let's say we have dog one. Okay, you have to write the class name, that is dog for us, followed by parenthesis. Okay, this parenthesis will actually contains the parameters if there is a need of parameters. Since we don't have a need here for the parameter, we have kept as empty only. Now, how to access the elements of this class attribute? Okay, since we know that in this class we have an attribute sound, to access this, how we can do it? We will use it out, as I told you earlier, to access these attributes you need to use a dot operator. So here also we'll use a dot operator to access the class attribute. So let's write print dog1 dot sound. Sound will be the name of the attribute that you want to access. Okay. Let's run this video. Okay. Okay, so here it's basically going to, yeah. So we have created a small class named dog, which has an attribute sound that has a value bark. Now, in the second step, we have created an object that is an instance of a class dog. Now we want to access the attribute of the class, which is sound. So what we'll write? We'll write dog1. Basically, how you can access? You can only access the attributes from the object, not from the class. You cannot write here dog. You always need to have the instance of an class that is object. And here the name of our object is dog1. So dog1 dot operator will use and will write the name of the attribute that you want to access. Okay. So now let's see the initiator in this. That is the init function. So in Python, a class has an init function. It automatically initializes object attributes when the object is created. Okay, so if you have not initialized your attributes, this function is going to do it. Let's write here. Class has a init. Okay, so there are going to be two underscores here. Okay, init function, it will automatically initializes the attributes of a class when the object is created. Okay, let's see a piece of code to see it's working. How does this works? Okay, let's see. We have a class doc. Okay, okay. Let's see. We have a attribute species here. Let's see. We have mammals. Okay, I don't know whether it's belong to mammals or not, but since we have just kept as a value here, then remember, I need to remember this. This is a class attributes. Okay. Now, as I have told you earlier, that to define any function, you need to have the usage of word def. Just now, since I told you this is a function, you need to have the def keyword over here. Then we'll write this. Okay. Let's say it has got uh, two other attributes that are basically the instance attributes, meaning these attributes are the attributes of an instance or the class. Say we have age as well. Now we'll write self dot name is equal to name. Then we'll let self. I'll give you an explanation to this code. Age. Okay. Okay. So for this piece of code, class dog defines a name class dog. So this dog is basically a class. Here the species is in class attributes that will be shared by every object. Okay. So remember that this species is a class attribute and these are instance attributes. Okay. So this species attribute, this is a class attribute and it will be shared by every instance of the class. How many objects you create, this species attributes will be there. Okay. This init method, it initializes the name and age attributes when a new object is created. Okay. So whenever you create an object of a class dog, this init function is going to initialize the value for the name and age attributes. Okay, now let's see how we will create an object for this class dog, and we'll see how this init function basically works. Let's say if we have an object name as dog1. Okay, since I told you, this now has to be given a name. Like this needs to have a name and age. Let's say we have a Tommy. Let's say it's 3 years old, maybe. Okay. Now to print the name and age of this dog, that dog1, that is an instance of a class dog, we need to access the attributes. To access the attributes, what I told you, that you need to write, you need to use a dot operator, which has the basic syntax as object name dot attribute name. So let's see how you can access the name and age of a dog1 instance. Okay, we'll write dog1 is the name dot name. Okay, then we'll, for the age, we'll write dog1 dot age. Okay, dog takes no arguments. Okay, you need to define the arguments here. Okay, so there's some problem. So basically here, if you copy this code, wait. So basically this code is has created a class dog that has an class attribute as species that will be that will be shared by each and every object created under this class. Also, it has a self initializer function which is init. It initializes the attributes attribute is whenever a new class is being whenever a new object is being created. Let's move this first. Also, also, then for creating an object of a class, we know that we will write the name for the object, which is, let's say, dog1 we have kept here, and then equals to, and then we'll have the name of the class. For to access the attributes, we know we'll write dog1, that is the object, dot the attributes we want to access. Let's say if you want to access Okay, so to access this, suppose you want to access the species. Okay, so there's a code, we'll see it later. Let's go to the explanation basically of this code. So this dog one creates an object of the dog class, which has the name as Buddy and a age 3. This dog1 dot name access the instance attribute name of the dog1 object, and dog1 dot species access the class attribute species through dog1 object. Okay. Now we'll see how the self parameter basically works. Okay, so self parameter is a reference to the current instance of the class. We have used here a self dot name and self dot age. So basically, a self parameter is a reference to the current instance of the class. It allows us to access the attributes and methods of the object. So a self parameter is a reference to the current instance of the class. It allows us to access the attributes and methods of the object. Let's create a class dog. Let's see if there's a cartoon. Okay, and now let's see dog one. Dog. Okay, so we got to know the error that we were facing in the few minutes ago. So here in this code, we have created a class named dog, which has a class attribute as species got the value as mammals. Then we have defined an init function that is going to that itself automatically initialize the attributes of a class whenever the object will be created. It has got two instance attributes. One is name and other is age. This self parameter is going to be doing it it's going to put a reference to the current instance of the class. Here we have created an object named dog1, which has got two instance attributes. One is age as the 3 and name as the Tommy. Now if you want to access the class attribute as well as the instance attribute, what you're going to write? You're simply going to write the name of the object, that is dog1 dot parameter we'll use, that is dot, and then we are going to name the attributes whatever we want to access. Now we'll learn about the self parameter. Self parameter is a reference that will put the reference to the current instance of the class. It also allows us to access the attributes and methods of an object. Let's see if you have a class dog. It has a function name, let's say bark. and has got the parameter self here. Okay, then we'll write print self dot name. Okay, now we're going to create an object. That is, let's say we have again a dog one as the object name, dog, buddy. Let's say give the age to 4. Okay, now let's see, we want to access this function which is bark. We'll simply write to access any attribute, variable, or any function. We'll use the dot operator, and that is basically, let's write print object name is dog1 dot function we want to access is bark. So we have a class dog here. We have a def keyword which has a function name as bark. Self parameter has been referenced here for the current, like to reference to the current instance. Then we have a print statement just to print that name. Then we have a object name is dog1. We have a dog name. Then we have got two parameters here. Then we have the function call. So this print statement. Okay, so there's another, I get there is a self parameter. Okay, so here basically self dot name refers to the name attribute of the object dog1 calling the method. Dog dot bark calls the bark method of dog1. Let's see str method. Okay, let's see str method. Str method in Python allows us to define a custom string representation of an object. By default, when we print an object or convert it to a string using str. String method in Python allows us to define custom string representation of an object. Let's see the code for this. Class dog. We have a class dog here. We have a def function. Self name comma each. Okay, so now we'll define the str function. So okay, let's remove this pass. We'll write the return statement here. That is, we write self dot name is okay. We'll use the curly braces here so that self dot name is actually takes the value, not a string. Self dot age years old. Now we'll create the instance for this class dog. One will be dog1. Another instance will be dog2. Into dog2. Okay. So this in this str function, which is defined inside a dog class, uses self parameter to a readable output. When the print dog is called, dog1 is called, Python automatically uses the str method. Without str, calling the print dog would produce something like a very like like address type thing. But in Python, variables defined inside a class can be either a class variable or instance variable, as I told you earlier. Like it can either be a class attribute or an instance attribute. Hence, these class variables are the variables that are shared across all the instances of a class. It is defined. It is defined as the at the class level, outside any method. Like no, these attributes are not defined inside any class, but they are at the class level. The instance variables are the variables that are unique to each instance of an object. For each instance, they are unique. They are defined within the init method or other instance method. Each object maintains its own copy of instance variable independent of other objects. Also remember that each object will have its own copy of its instances or variables, which are like independent of each other. Let's write these points. Basically, this is a difference between a class variable and a instance variable. So these are the variables that are shared across all instances of the class. They are defined at class level. all the objects, remember all the objects of the class will share the same value. Same value for the class attribute or a class variable. Now let's see instance variable. These variables are unique, that are unique that are unique to each instance, to each object or an instance of a class. These are basically defined inside the init method or any other instance method. Also, each object or each instance of an class will maintain its own copy of the instance variable, which are independent of each other. That are independent of each other. Now let's see a piece of code. We'll have a class named, let's say, dog. We have a class variable, let's say species. Then we have an init function. These are going to be instance variable. Self dot name equal to name. Self dot age is equal to the age. Okay. Now we'll create the object. We'll have the second instance as dog2 equals to dog. Let's say Charlie and 5. Okay. Now let's see, we have to print the attributes here. I will print the age. Similarly, we'll print for the dog too. Dog 2 dot name. Dog 2 dot age. Okay, so for the dog one, we got that the species is animal, name is Tommy, and the age is 3. For the second instance, that was dog 2, it's got a species as mammal, the name as Charlie, and the age as 5. As you know it, that since the species was a class attribute, it has been assigned a same value that I have told you earlier, that these variables that are shared among across all the instances of the class, all the objects of the object will all the objects of the class will share the same value for this class variable. So every each of these instances got the value as mammal. But when you come for but when you come to the instance variable, these value change upon the object. For this, it has been defined as Tommy and age 3. For this, the name was defined as Charlie and the age was 5, and hence it was being printed. Okay, so here the class variable shared by all the instances has got the same value, and it was shared by all the instances of the class. Now let's see if we change the or modify some instance variable. Let's keep dog1 dot name equal to, let's say, Bruno. Okay. Now we'll write dog1 dot name, print to see whether the name is changed or not. Okay, so the name has been changed to from Tommy to Bruno. So this was basically to how to modify a instance variable. Now we'll see how you can modify the class variable. We'll write. Okay, as I told you that dog instance variable is the variable of a object, but the class variable is an attribute of the class. Since for changing this class variable, you need to write the class name, that is basically a dog. So we'll write species, the attribute we want to change, since we have defined only a one class attribute here. And let's see, we have okay. Now we'll print to see whether the changes have been reflected or not. Okay, the species name have been changed from mammal to animal. Okay, so the instance variables are accessed via the object, while the class attributes are accessed by using the class. Now we'll see encapsulation. This is basically a part of an object oriented programming language that basically refers to the process of hiding the internal state of an object and all the provide requiring all related data only. Refers to the bundling of data and methods. Data means attributes and methods mean functions that operate on data. Okay. Bundling of data and methods into a single unit. Okay, so this is in Python. Encapsulation is the process in which you bundle the data and methods into a single unit. It also restricts direct access to some components, which helps to protect them from the integrity. We'll write this. It also restricts direct access to some components which help protect the integrity. Now, in the lame language, if we say, then encapsulation is basically the process of hiding the internal state of an object. What is encapsulation in the very simple language? Encapsulation is the process of hiding the internal state of an object and only displaying. So basically, encapsulation the process of hiding the internal state, meaning only displaying that much amount to the user or to the uh, like the viewer that is just needed, and to hide all the internal data. So with this, what we achieve basically, that comes under advantages of encapsulation. It provides better control over data, provides better control over data, prevents accidental modification of data. Like by chance, if some data is being changed and it will prevent it. And also promotes modular programming. Promotes modular programming means a better scope for the users to modify the code, and a type of code that can be accessed and used without any bugs. So how in Python we achieve this encapsulation? The basic question that comes is how in Python we achieve this encapsulation. Okay, we achieve this using data hiding and using the access modifiers that are basically in Python we use three access modifiers that are public, protected, and private. We keep this we define the type of access modifier to each variable or an attribute that will achieve the encapsulation in our code in Python. So the variables or attributes are kept either private protected, meaning they are instead they can only be accessed or modified through the methods only. Methods act as the interface which external code interact. For instance, getters and setters are common method used to retrieve and update the value control. By encapsulating the variables and only allow their manipulation of the class, and the class can enforce rules on how the variables are accessed or modified. Let's write we achieve encapsulation through public, protected, and private access modifier. Okay, so this basically helps in data hiding. By for your note, if you don't provide any access modifier to your variable or to your attributes, it will automatically will be taken as public. It's a default access modifier in Python, right? Public is the default access modifier in Python. So let's just give, okay. Okay, just give me a minute. I'll return in a minute, please. Okay, so we were discussing about the encapsulation in Python and how we can achieve it. We can achieve it using the access modifiers that are basically public, protected, and private. Encapsulation has the following advantages: it provides better control over the data, it prevents accidental modification of any type of data, also, it promotes the modular programming. One thing that I need to mention here is that public is the access default access modifier in Python. Like if you do not provide any access modifier to your attributes, public will be taken as a default one. Now we'll see now we'll see these each each modifier one by one. First, we'll say for the public. So any attributes that are defined as public are accessible from anywhere. Both inside and outside the class. As I told you, these are the default access modifier in Python. Let's see a code for this. We'll say we have a class public. We have an init function here then. Okay. We just have got a self as the parameter here for to reference the value for each initialized instance variable. Okay. Here, if we do it as self dot name. So we have okay. We have another function. Let's say to display the name, we have another function defined. I've also got the self parameter. Okay. We'll write print self dot name. So this is a public attribute, and this is a public method. Okay. Now we'll create an object for this. Let's say we have an object obj, and we have a class as public. Okay. Now we'll write object dot display name to display this function. Okay. Then we'll write print object dot name. Okay. We have created a class that's name is public. Then we have a init function that has the self parameter and is basically defining the name to be Joe. Then we have a display name as a function that is a public function or a method, and that has got the parameter as self that is going to reference the initial value to the object. Now we're going to print this self dot name here. Now we have defined an object here, and we wanted to display. We need to access this display name function and the attribute that is public attribute name. Okay, so it has basically printed the Joe that has basically done the same function. Both of them have performed the same thing. Here the public attribute is declared without any. Okay. Remember, for one thing I need to tell you about for the init constructor is init method is a constructor. Is a constructor and runs as soon as the object of the class is created. And runs as soon as the class of the object is created. Now let's see another type of access modifier, that is protected. So protected access modifier are identified with single underscores, and they are meant to access the to access the variables or any attribute to a certain limit. Let's see a code for this. Let's say we have a class name protected. Then we have a function name, a constructor that is in it. Okay. We'll have a parameter self here. Okay. Now we'll write self dot. Now we will use a single underscore here, and we'll write age equal to, let's say, 31. Okay. So here this underscore basically defines that your attribute age is no longer the public one and is now being converted to a protected access one. Now create another class. Let's have a name to this as subclass. And now you put this class protected inside it. And we have a function def. Let's say for to display the age, we have a display age function. Okay, we'll have the self parameter here. Okay. Now we'll write print self dot age. Print self dot age. Now we'll create an object for this class. Let's say we have our object as obj. We have the subclass and we have the object dot display. Display age. So this is basically a code. If you want to have any attribute as a protected access modifier, where we will only, in case of public one, we just simply write self.name. But in case of protected, you need to have a underscore before after the dot operator to make it look that it is a protected. Let's write that it's a protected modifier. Here it has been protected in subclass. So here this underscore age attribute is prefixed with single underscore, which suggests that it should be treated as a protected member. It's not enforced by Python, that indicates that it should not be accessed outside of this class. Here, a subclass inherits from the protected class. Within this subclass, we can still access the protected attributes, that is age for us. Here the method display age, this method is within the subclass, access the protected attribute age, and this shows that the protected members can be accessed within the class and its subclass. So for the public members, what we know that they can be accessed anywhere around the code, even it could be inside the class or it could be outside the class. In case of the protected members, they can only be accessed inside the class or inside the class subclasses that are inherited by the parent class. Now let's see the third type of member, that is a private. So the private members are identified with a double underscore and cannot be accessed directly. Let's see a code for this. Let's see, we have a class private here. We have a function def init self as the parameter to reference. We have a used a double score underscore just to reflect that it's a private member. Let's say we have 10,000. Okay. Now we will have the another function. Let's say it's salary. It has also got the parameter as self here. Okay, now we'll create the object for this class. Let's say we have the object name as obj. Okay, so we have created an object for this class private. Now if we write a print statement, to print the salary for the class object. Also, if we write another print statement, let's say this object dot double underscore to reflect that it's a private member. Okay, so this here we have a class private. Under it we have an init function that has got the parameter self to reference the initial value for the object. Then we have defined a new function salary that has also got the parameter self, and it will return self, that will return the self dot salary. Here the salary has been used with double underscore to reflect that it's a private member. Now we have created an object for the class private. We have tried to print the salary for this object. We try to print the salary using the um salary function, and we just try to do it simply using the init function. So the first print statement would work, but the second print statement would result into an error that is known as attribute error here. This attribute error is basically to let you know that it's a private member and it can only be accessed inside the class. Also, if you try to access the private attribute directly that we have tried to do it in the second print statement, it will result into an like it will try to like go out of the encapsulation model that is defined inside the Python. So this was about the class. What did we studied in class was that class is a user defined template for creating any object. This template can be used anywhere by creating the object. The attributes that are defined inside the class represent the property of a class, and we can access these attributes using a dot operator. Also, we saw how we can create a class, how we can create an instance of a class that was object, how this init function will automatically initialize the attributes of a class when the object will be created. We saw how we can access these attributes using an example of a class dog. Then we saw how we can use the self parameter to reference the current instance of the class. Then we saw what is the use what is the use of str method in Python that allows us to define a custom string representation. Then we saw what is the difference basic that is what is the basic difference between a class variable and an instance variable. Class variable is basically a variable that is shared across all the instances of the classes, and they are defined at the class level. All the objects of the class will share the same value for this class variable. And coming on to the instance variable, these are the variables that are unique to each object of the class, and the object will create its own copy for this instance variable, and they are independent of each other. Then we saw an example of a class dog where we defined the two instances of this class dog. We tried to access the attributes associated with it. We had the species as the class variable or the class attribute here, and the name and the age as the instance attribute here. Then we tried to change the instance variable and the class variable. But for changing the instance variable, the only variable will be changed that are associated to a particular class. Like if you change the name for a dog1 object, it will only be changed for it. But if you try to change the values, or you wish to modify the class variable, the all the instance of the class will have the values changed. Then we saw the encapsulation, which basically refers to the bundling of a data and methods into a single unit. It also restricts the direct user access to some components of the code, which helps to protect the integrity of the code. Encapsulations comes with the three advantages that are basically it provides better control over the data, it prevents accidental modification of data. It promotes modular programming. In Python, how we achieve encapsulation? Encapsulation in Python is basically achieved using the three access modifiers that are public, private, and protected. The public members are accessible anywhere, both inside and outside the class, and the protected access modifiers is only accessed inside the class and the subclasses that are inherited by the class. The private members are only accessed inside a class, and they can never be directly be called. Just in case of a second print statement, we got to know that this will raise an attribute error. That's right here. It will raise an attribute error. Okay, this works. Okay. Then we know that the init method is a constructor and runs as soon as the class of the object is created. Remember, if you do not define an init function, it will have no error displayed. The Python will automatically call this constructor and run as soon as the class of the object will be created. This was all about the classes and objects in the Python, and how basically the object oriented programming is done in Python. Object oriented programming is very different from the functional programming that we know. Now we'll see some of the exceptions and the errors that we encounter while we write a program in Python. Exception handling in Python. So errors in Python can be of two types. It can be of syntax error or can be exceptions. Write a multi-line comment. Let's see. Number one is syntax error. And the others are exception. These exceptions. Okay. So errors are problems in a program. Errors are problems in a program due to which the program will stop the execution. On the other hand, exceptions are raised, some internal event occurs which change the normal flow of the program. Let's write this. Errors are the problems in a program due to which the program will stop the execution. Whereas exceptions are raised when some internal event occur which change the normal flow of the program. Okay, let's see some of the different types of exceptions in Python. So in Python, there are several built-in Python exceptions that can be raised when an error occurs during the execution of a program. Some of the exceptions I want to tell you here is syntax error. sixth syntax error. Exception. This exception is raised when the interpreter encounters a syntax error in the code, such as a misspelled keyword, a missing colon, or an unbalanced parenthesis. So, syntax error is basically due to some of the uh, problem, some of the problems in the code itself. That is, either it is could be a misspelled word, or it could be a parenthesis issue. It could be missing colon. The other one is type error. Okay, that's the other one is type error. This exception is raised when an operation or function is applied to an object of the wrong type, such as if you are adding a string and an integer, this will result in a type error. The third one is name error. So this exception is raised when a variable or function name is not found in the code. Suppose if you have any variable and you want to, if you have a name assigned to it, and in the later code you try to like you try to print that, or you try to take a use of that variable with another name, this will result into a name error. Then we have a index error. So this exception is occur when the index is out of range, and it is basically for a list, tuple, or any other subsequent data types. Suppose you have a, a list that consists of three elements, and if you try to access the index, suppose three, so this three is not a index that belongs to that list, and it will result throughout an index error, saying that it is out of bound. And then next we have a key error. Okay, key error. So basically this key error is only for dictionary, when the particular type of a key, when a particular key is not found in the dictionary. Next we have a value error. This value error. This exception is raised when a function or a method is called with an invalid argument or input, such as trying to convert a string to an integer when the string does not represent a valid integer. So this value error is basically will basically occur when you want to, when if you wanted to like when you found to have an attribute or method that is not found on an object and will be considered as invalid. Suppose that we want to convert a string to an integer, and that string does not contain a valid integer value. Next we have the attribute error, and this is basically for the classes and object only that we studied in the previous section of this lecture. Yes, attribute. This exception is raised when an attribute or method is not found on an object, such as trying to access a non-existent attribute of a class or an object. Let's suppose if you want to, if you have several attributes already defined inside the class, but if if you try to access any of the attributes or method that is not defined only, that it will result into an attribute error. Next we have IU error. So this exception is raised when an input output operation such as reading or writing a file fails due to an input output error. Basically, when you write in a file or you take an output from the file, this exception will occur if any of the input and output operator is not able to perform that task. Then we have a zero division error. Okay. So here we have this zero division error where in which this and if you divide any number by zero, it will result into the zero division error. Then we have an import error. This exception is raised when an import statement fails to find or load a particular module or a library. Suppose you want to import a library or a module that is not that the compiler or the interpreter is not able to perform and import it, then this exception will be raised. Let's see a code which will show up how this error work. Okay. As the name suggests for the syntax error, this error will be caused when the wrong syntax in the code will be used, leading to the termination of the program. Let's see, we have a variable count is equal to, let's say, 5. Okay. Now write a fixed statement. If count is greater than 0, print count. Let's say. So this code will basically result into an exception, that is syntax error, because we know that from the basic syntax of a conditional statement that if is followed by a condition which is further followed by a colon. Since we have not used a colon here, this will result into a syntax error. So a syntax error is basically caused when you use a misspelled word which is not a keyword for a Python language. You have an unbalanced parenthesis, or you forgot to use a colon, then it will result into syntax error. Okay. Also, one thing that the exceptions are raised when the program is syntactically correct, but the code results in an error. This error does not stop the execution of the program, however, it will change the normal flow of the program. Let's see this. If we have some marks as 100, okay, and we have a new variable, let's say a, which will be divided by 0, and if you print the same, let's see. Okay, division by 0. So this is basically a zero division error where you cannot divide a number by 0, since this is invalid statement in the mathematics. Also note, exception is the base class for all exceptions in Python. For example, any exception or error that is there, it comes inside the exception class. As I told you that there is a class and there are subclasses inside it. Similarly, the exception is the base class of all these errors and exceptions. Now we'll see a type error. I told you that in a type error, what basically the problem comes in is, you try to, like, if you try to add a string variable and an integer value, it's not possible, and hence it will result into a error. Like, either you convert both of them to a string, then there will be a concatenation, or either you have this string variable to an integer so that it could be added as per the laws of the mathematics. Let's say we have a variable x which has a value 5, and we have the variable y which has a value as hello. We have a, let's say, a z variable that will basically show the addition of both of this. We like print. Okay. Okay, so this will be a type error stating that unsupported operand type for plus intent string integer string cannot be added. Now we'll see try and except statements that will catch the exceptions. Try and except statements are used to catch and handle the yeah and handle the exceptions in Python. Statements that can raise exceptions are wrapped inside the try block. Try block and the statements that can handle the exceptions are wrapped inside the catch block. The catch block. Sorry, yes. Inside. Inside the except block. To handle the exceptions, you have the except block, remember. Okay. Suppose. Okay. Now if we have a list, let's say A that contains the value 1, 2 and 3. We have this try block, so a try except block. Try is a keyword here, remember. Print second variable, so second element. Second element is equal to A1. Okay, yes. Let's say we want to print the fourth element. Since we know that there is no fourth element inside the list. Okay. Now we'll have the accept block defined. Print error. Suppose an error occurred. Okay. Let's say we run this code. Okay. So second element has been printed, which was 2. For the second print statement that said that print the fourth element, since our list only contains the 3 element, this is an error. This error has been challenged or be taken care by the except block that has the print statement that has an error occurred. So in this example, the statements that can cause the error are placed inside the try statement or the try block. The second print statement tries to access the fourth element of the list, which is not there, and this throws an exception. This exception is then called by the except statement. Now we'll see the catch specific exceptions. So a try statement can have more than one except clause. Can have more than one except clause. A try statement can have more than one except clause to specify the handlers for different expressions. To specify the handlers for different exceptions. Also remember that at least one of the handlers should be executed. At least one of the handler should be executed. Let's for example if we add an uh, index error in the above code, the general syntax for adding a specific exceptions are, let's see the syntax for this. We have a try statement first of all. Then we have several statements, let's say. Okay. Then we have the except. Let's say we have an index error on this. These are the handlers will be defining the handlers for the different exceptions. Statement statements except, we have another except statement defined which will sort the value error problems. Okay, let's see, which will be again be followed by some statements. Okay, now let's see a program or a piece of code that will demonstrate all of this. Okay, now let's see, we have a function def fun and we have a variable. Okay, if a with 4. Okay, let's see have a b variable equals to a divided by a minus 3. Print, let's say we print this value of b, value of b is equal to, now we will have the try and the except block defined. For the try, as I told you, we'll have this try colon, and we'll have the functions. Let's say if we call this function fun with the parameters 3, let's say I have 3 and 5. Okay, fun, that's 5. Okay, and now we'll see the except block. Also, we know that we are going to define those statements that will carry the errors in the try block, and the exceptions or the things that will be displayed on a screen for related that to that query will be defined inside the except block. Now we'll have this except. Let's say it is a zero division error. Print, let's say if we print this, print zero division error occurred. Okay, now we'll have the second except block defined to handle the another type of error, that is name error. Name error. Now we'll see the print statement for this. Print name error occurred. Okay. If we execute this, okay. So division by zero error has been occurred. Now we'll see for the try with else clause how we can use this. Try with else clause. Okay, in Python you can also use the else clause on the try except block, which must be present after all the except classes. Except clauses. The code enters the else block only if the try clause does not release any exceptions. Okay. So for this try with else clause is basically a thing. We define the try block, then we have several except blocks below it. If there is no error occurring, if there is no error that is matching to those except blocks, then this else block of code will be executed. Let's see it with an example. Def, we have a say a function. We have the two variables. Let's say a comma b. Now, let's see we have a try block inside this function only, and we'll have this. Let's see c is equal to a plus b into a minus b. Let's see a plus b, a minus b. Okay, now we are going to define the except blocks. Except block is, we say we had zero division error, zero division error. Let's say print a by b results in 0. By b results in 0. Okay, yes. Now we have the else part defined, which will basically see the functioning over here of this else. print C. If there is no error occurred, meaning A by B is a valid option, then we'll print this C. Now we'll call this function, let's say fun 2.0, let's say divided by 3.0. Okay, found the function again and we'll say 3.0 divided by 3.0. Okay. Okay, I need to define this, yes. Yeah. So for the first one, you got that the minus 5 is 5 minus 5.0 is the answer, whereas in the second, this error has been released. Okay. Now we'll see the final keyword in Python. Finally, keyword in the final keyword. Final keyword in Python. So Python provides a keyword finally, which is always executed after the try and except block. The final block always execute after the normal termination of the try block or after the try block terminates due to some exceptions. The code within the final block is always executed. Okay. So in this, the final keyword is basically the final keyword in the Python is basically used after every try and except block. This final block will be executed. Let's see. Let's see the syntax for this. Syntax. Let's see the syntax for this. Try. Let's see. We have some statements here. Code. We have code here. Okay. Then we have the except block. Then hashtag we again have the code here. Okay. Then we have, let's say we have an else block also defined here. We again have the code here. Okay. Then we have the finally block defined here. We'll again have the code here. Some piece of code that will be executed. Remember, this except block and the else this except block will be only executed if there is a particular type of error found that is there in this except block. Else will be executed if there is no error found in this except block, meaning there is no match of these type of exceptions or the errors, then only the else block will be executed. But in case of the final block, this will always be executed. This try block will contain basically the code that will result into an exceptions and errors. Let's see this. Let's see our try block. K is equal to, we have a k variable k that has 5, floor division 0, and we try to print this except 0 division error. Okay, now if we print this, can't divide by 0. Okay, can't divide by 0. Now if you have the final block defined here, we have not used the else block since it's not a mandatory thing. Finally, if we print, this is always executed. Okay. This is always executed. This is always executed. Okay. Then this, if you execute this, okay. So it's saying that we cannot divide by 0 since this is an exception. Also, this final block will always be executed. Now, if you see the exception, how we can raise the exceptions. So let's write raising the exceptions. The raising the raise statement allows the programmer to force a allows a programmer to force a specific exceptions to error. The sole argument in raise indicates the exceptions to be raised. This must be either an exception instance or an exception call class. Okay. Okay, in raising the exceptions, what we'll basically see that the raising statements allows the programmer to force a specific exceptions to occur. The sole argument in raise indicates the exception to be raised. This must be either an exception instance or an exception class. Let's see this using a code. If we have a try block defined here, raise, we use the raise keyword. Name error. Let's say hello. Okay, hello. Okay. And we have the accept block here. Accept name. Name. Then we'll write print. There's an exceptions. An exception occur. Okay. We'll again have the keyword raise here. Okay. An exception occurred, and this will forcefully ask the interpreter to raise an error. Now we will see some of the advantages of exception handling. By handling the exceptions properly, you can prevent your code from crashing or producing incorrect results due to unexpected errors or inputs. Also, exception handling allows you to separate error handling code from the main program logic and making it easier to read and maintain your code. With exception handling, you can avoid using complex conditional statements to check for the errors. When exception is raised, the Python interpreter prints a trackback that shows the exact location where the exception has been occurred. So, in the exception handling, we discussed about the what is an exceptions. What There are two types of errors, basically syntax errors and exceptions. Errors are the problems in a program due to which the program will stop the executions, but the exceptions are the some internal event that will cause the that will change the normal flow of the program. Some basic types of errors and exceptions that we encounter in Python are syntax error, that is caused basically due to a wrong syntax. Type error is basically caused due to, suppose if you want to add a type string and integer, it will result into a type error. Name error is basically if you do not have the particular variable design and you wanted to and you use it somewhere in your code. The index error will basically result for the list, tuples, dictionaries which are out of range. Key error is basically if you do not found any type of a key in a dictionary. Value error, then we have the attribute error. Attribute error is for the object where you cannot find a particular attributes for our object. Input output error is basically when you try to perform the input operation task and the input and output operators cannot do it. Division by zero division error is basically